Early on in many college algebra textbooks, the author wants you to graph a function without really necessarily knowing what this graph is going to look like, and be given a set of x values that they want you to fill in the y values. And so you're going to plug in each of these numbers. Here's the t-chart all filled out. If x is -5, y is -5, giving us the point -5, -5 on our graph. If x is -4, y is -2. You'll notice here, this is when x is -3, y is -1. This is the biggest y ever gets, and then when x is -2, it goes back down again, -2. You'll see some symmetry, -5, -2, -2, -5. So there's some symmetry in this graph. You get repeated y values. Let's go to WileyPlus and see how this turns out. You remember this key point here when y is the biggest it ever gets at -3, -1. Okay, WileyPlus only gives us a few choices of what it can be. This graph can't be it because this doesn't ever have repeated y values. Let's get rid of that. The x gets rid of the selected object, clear gets rid of everything. It's not going to be this one. We do have some repeated y values, but y doesn't ever get to a maximum value. It just keeps going, and so we don't want that one. We don't want this one. Once again, you don't have any repeated y values, and we know we've got that. So let's try this one. Is this going to do what we want? It's got a y that is bigger than anything else. That happened at -3, -1. Notice that we don't see coordinates at this point, so just try to get it to that point as close as you can. It looks like it is going through those other points we identified, -4, -2, -2, -2. Looks like it's going to be going through -5, -5. So that's enough for WileyPlus.